Somewhere out there, 124 light-years from Earth, a planet orbits a dim, red star. It's wrapped in thick clouds of hydrogen, and beneath them, it might hold something incredible. This is K2-18b. Some scientists believe it could support life. Others say it's too soon to tell. But either way, the mystery has returned to the spotlight. And what we're discovering might just change everything. K2-18b was discovered in 2015 by NASA's Kepler Space Telescope. It's what scientists call a subneptune. Larger than Earth, but smaller than Neptune. About 2.6 times Earth's size, and nearly 9 times heavier. It orbits a red dwarf star named K2-18, located in the constellation Leo. Even though that star is smaller and cooler than our Sun, K2-18b sits right in the habitable zone, the region where liquid water could exist. Now, that doesn't mean it's like Earth. In fact, it's probably very different. But this strange world has something special. An atmosphere. And we're just beginning to understand what's inside it. Red dwarf stars like K2-18 are the most common stars in our galaxy. They burn cooler, use up fuel slowly, and can live for trillions of years. That long lifespan makes them very tempting targets in the search for life. But there's a problem. Red dwarfs can be violent, blasting nearby planets with powerful flares and radiation. So, for a planet like K2-18b, life would have to adapt to those flares, or be protected by a thick atmosphere, or a deep ocean. In 2019, the Hubble Space Telescope spotted something big. Water vapor in K2-18b's atmosphere. That alone was huge. But then came the James Webb Space Telescope. In 2023, Webb detected methane and carbon dioxide. Both intriguing, but together, they hint at a carbon-rich environment. And that raises a stunning possibility. There might be a liquid water ocean hidden beneath the atmosphere. But here's the most astonishing part. Webb may have detected a molecule called dimethyl sulfide, or DMS. On Earth, this chemical is produced almost entirely by life, especially by tiny marine organisms, like plankton. If that signal is real, it might be our first sign of alien biology on another world. But how do we even know what's in the atmosphere of a planet we've never seen up close? The answer is transit spectroscopy. When K2-18b passes in front of its star, some of the starlight filters through its atmosphere. Different molecules absorb different parts of that light, leaving behind a kind of chemical fingerprint. Webb picks up on those faint imprints, like whispers from another world. That's how we found water vapor, and possibly DMS. K2-18b may belong to a new category of planets, called Hycean worlds. The name blends two words, hydrogen and ocean. Picture this: a planet entirely covered in water, with a thick hydrogen atmosphere blanketing it. The ocean could stretch for thousands of kilometers. No continents, no land, just deep, alien seas. And get this, Hycean worlds might actually be more common than Earth-like planets. Some scientists even believe they could be better suited for life, especially simple, microbial life. So, what would life on K2-18b actually look like? Probably not intelligent aliens. No flying saucers. But maybe microbes. Tiny organisms floating in the ocean, feeding off chemical energy, not sunlight. Here on Earth, we found microbes living deep in the ocean, near volcanic vents, in complete darkness, under crushing pressure. If they can survive here, maybe something similar could survive there. Alien life, built from different rules, but still alive. But let's not get ahead of ourselves. That possible DMS signal? It's not confirmed. Webb's data shows it with 99.7% confidence. Sounds impressive, but in science, that's not enough. The gold standard is 5 sigma, or 99.9999% certainty. Until we reach that, it's just a strong possibility. And even if DMS is there, we can't automatically say it came from life. There might be unknown chemistry creating it, deep inside the planet. The truth is, we're still figuring out how these alien atmospheres even work. Some scientists wonder, is K2-18b really habitable at all? Its atmosphere could be extremely dense. The pressure at sea level, if there is one, might be strong enough to crush any living thing. And K2-18b might not even have a solid surface. Just clouds, gas, and maybe an ocean floating above a molten core. But others argue, life doesn't need a surface. Floating microbes could thrive in certain layers of the ocean, protected by clouds, feeding on chemical reactions deep within. Whether K2-18b holds life or not, it still represents something huge. Our technology is now powerful enough to study distant exoplanets, not just their orbits or sizes, but their atmospheres. And if we do find life here, even something tiny, it would mean life is probably common in the universe. The Drake equation, used to estimate the number of civilizations in our galaxy, would suddenly feel a lot more optimistic. Maybe we're not alone. Maybe we never were. K2-18b is mysterious, fascinating, still full of secrets. But it's the kind of mystery that pulls us forward, into space, into the future, into a deeper understanding of what it means to be alive, in a universe that might be teeming with life. Thanks for watching. If you enjoy these deep dives into space and science, hit that like button, subscribe, and stick around, because this journey is just beginning.